All right. All right. No. So I put the test review out. We're doing that next class, but it seems like some of you, I love this about you, want to try it on your own before we do it together. So I just went ahead and copied it ahead of time. But what I do not want is if you take it today, don't leave it at home because it's like 4 pages and we're going to kill all the trees if I have to make double copies. So if you take it, bring it back with you next class, and then your test is the B-Day after that. Okay? All right. All right, are we ready? Yes, we're ready.
Again. Oh my god, I keep on thinking it's Friday. Oh my god, me too. I know, again, but I gotta go see them.
Okay. Well, but you yeah. All right. So what we are doing today is we are going to revisit the limit definition of a derivative. And we are gonna then do a second limit definition of a derivative. Okay. All right, so will you take a look at the graph on your paper? Okay, this is what we did. I know it's been like maybe 3 weeks since we learned this. You're going to take 2 points. Okay. Okay, and you are going to calculate the slope of the secant line. Now, if you don't remember why it's called the secant line, it's because it crosses the equation twice. So the slope of the secant line would be f of x plus h minus f of x over x plus h minus x. So that equation, just so that you know where it comes from, is y2 minus y1 over x2 minus x1. Okay, and then if you remember on the day that we covered this, we looked at the bottom and said, oh, if it's a plus and a minus x, those can just kind of cross out. So the slope equals, secant slope equals, and then we're going to cross those x's on the bottom out because they are always going to cancel, so you can just kind of leave them out. Okay, to turn your secant slope into a tangent slope, which is what a derivative is. Okay, so let's put tangent slope. You are going to use the exact same fraction, but x plus h minus f of x over h. But you are going to drive the points so close together that basically instead of touching 2 different points, you're just touching 1 point. So the way that I do that is I'm going to do a limit with h approaching 0. Okay, and that will give you the derivative, which remember for the AP test, pretty much you would use your rules for. Okay, but one more time, I find the secant slope, that's this, y2 minus y1 over x2 minus x1. And then I take my h, the distance between the points, and I drive it to 0 so that basically the points are right on top of each other, that it's like a tangent line instead of a secant line. Okay, so let's practice, and then we're going to add the second version of this. So you have f equals square root x. First, we're going to take the derivative using the rules. Now, a square root is an advanced derivative because it requires a rewrite. What rewrite would I use for a square root? A half. Very good. So we're going to do x to the half, and then we're just going to take the derivative. So f prime of x equals, my 1/2 is going to times down to the front. And then do you remember we need to take away 1? What is a half take away 1? Negative 1/2. Then we would rewrite it as 1 over 2 root x. Okay, that would be using your rules. Takes like 30 seconds. All right, now we're gonna do it the limit way. So I want you to write f prime of x equals LIM, h approach 0, f of x plus h minus f of x over h. Okay, and then remember, this is now taking the derivative using the limit definition. Okay, first question, what am I going to put in the f of x spot? What is f of x equal to? Very good. So f of x is the square root of x. Then f of x plus h would just be the square root of the x with a plus h with it. So remember that when you're changing your f of x to an x plus h, you're basically just sneaking the h in where the x was. Okay, then we're going to take those two chunks. We're going to put them into our equation. So this chunk is going to go here.
Is the square root in h2?
The h is in the square root. Yes, ma'am. Okay, and then this green box is going to replace this green box. Okay, so my new equation says LIM, h approach 0. My first square root has an x plus h in it. My second square root only has an x in it over h. Okay, now from here, I want you to think about last class. We learned 4 limit strategies. Okay, plug it in, factor cancel, conjugates, and L'Hopital's rule. Which one did I use to solve limits that had square roots in them?
Conjugates.
Conjugates, very good. So we're going to take the top and we're going to multiply by the conjugate. So remember, the conjugate, you just switch the sign in the middle from a minus to a plus. So it'll be root x plus h plus root x. Okay, conjugate. And then remember that if I want to multiply that on top, I have to also multiply where else?
At the bottom.
On the bottom. Now remember, for the bottom, we're not going to times that out. Okay, why not? Because they're not even conjugates of each other anyways. We only want to times out the parts that are conjugates. So the bottom, keep it identical. So LIM, h approach 0. I'm going to have an h and then a root x plus h plus root x. So we're not doing anything to the bottom. Okay, but for the top, we're going to actually multiply it out. So here we go. What is the square root of x plus h times another identical square root of x plus h?
X.
X plus h, very good. Okay, because remember, a root x times a root x, you just keep the x, then a root x plus h and another root x plus h, you keep the whole thing on the inside. Okay, the next term is a root x plus h times a root x. So just put those together. You're going to have an x plus h and a root x. Okay, now we're on in our FOIL, we're on the I, that's the insides. So I'm going to do this guy times this guy. And what do I notice about my inside term compared to this one I just wrote? It's almost the same, except instead of a plus, it's a minus. And remember, that should always happen with conjugates. Okay, and then for my last term, it's a minus root x times a root x. That's going to become a regular x. Minus x, thank you, yes. All right, then, because, yes? You could, if you wanted, times the x and make it an x squared plus 8x, hx. I just am not going to because they're going to cross out anyways. Okay, so cross your middle two terms out. Okay, remember that's what we love about conjugates. Okay, is that the middle two terms are always going to eliminate. So on top, that leaves me with an x plus h and a minus x. What else is going to cross out? The x's. So the only thing I'm left with on top is now a what? An h. Very good. So LIM, h approach 0. All that we're left with on top is this one little h. Everything else crossed out. So I have h over another h, root x plus h plus root x.
You can just get rid of the x's like that, even though it's plus
So it's a
something.
plus x in the
Right,
front and a
minus.
minus x in the back.
Right, but it's plus something, and it's the parentheses don't matter.
Exactly. Because there's nothing outside of it you would need to times it.
Yeah, okay.
Okay, from here, anything else that could?
Yeah.
Okay, and if everything crosses out from the top, what do I have to leave as a placeholder? 1. Okay, now that my h is gone, I'm going to retry my limit. Remember, that's the whole point of the conjugate, is you want to eventually plug that number in. What is my h approaching? So then I'm going to have 1 over root x plus 0 plus another root x. What is root x plus 0 the same as?
0.
So root x plus another root x. How many root x's are on the bottom? 2. 1 over 2 root x. And what answer did we get when we did it the short way? Oh, wow. Look, it's the same. Look at math.
Wait,
Look at that.
I'm like at the right.
We will not. I'm just trying to remind you of it so that
Yes.
your notes and homework today make sense.
Notes today
Okay.
at home or like this?
Yeah, these notes
Oh, shit.
and then the homework for today. Yes? Because root x plus another root x would go to 2 root x. Because you're combining like terms. It'd be like a 1 root x plus a 1 root x goes to a 2 root x. All right, turn the page. All right, so here's what you're asked to do on your homework. This is a little bit different than the first time that we tested it. Okay, for this first page, or the first part, this is what we did last time. Do you remember that what I had you do for this homework, okay, even though we know it was a long time ago, is you circle the function behind the minus, and then you just take the derivative. Do you remember that? Okay, that's okay if you don't, but you're going to circle f of x because remember, in the formula, it's behind the minus, and then you're just going to take the derivative.
Of f of x, right?
Uh-huh.
Okay.
So if my function is tan x, what would I get when I take the derivative of that?
Isn't it like negative secant?
Secant squared x, yes. Okay, no negative because remember, the negative is part of the limit definition. That's why we circle what's behind the minus sign, not including.
Which one's the one that gives you negative cosine, or what are the ones that give you negative? If it
Ones
has
that
a
start
C?
with C.
The ones
It starts
just
with C.
cosine.
Cosine, cotangent, cosecant.
Cos-
All right, now take a look at number 4. It's almost the same, except do you notice that where your x is, there's a number in that spot. So the only difference from number 2 to number 4 is that for this one, you're going to still take the derivative, but then you're also going to plug in the pi thirds. Okay, so if they replace the x with a value, then you would have to plug that value in. Now, what did we already say the derivative of tan gave us? Secant squared x, and then I'm going to plug in for my x pi thirds. Very good. Now, I know that we haven't done a ton of secants, but let's kind of start thinking about it now that we have hopefully sine and cosine under wraps. Secant, I want you to write on your paper, is the reciprocal of cosine.
Okay.
So all that means is you're going to find the answer for cosine, and then reciprocal just means you're going to flip it. So can you find your pi thirds finger?
Yeah.
Which one?
No, pointer.
Pointer. Cosine's up or down? Up. How many fingers are up?
1.
Square root of 1 is,
1.
over 2 is a half.
1/2.
But I'm going to write 2 over 1.
So 2.
So it'd be 2. That's right. Now, that is the answer for secant. What was my answer? Secant squared. Then I need to remember to square it. Now, 2 divided by 1 is the same as 2. 2 squared would give me 4. That's your answer. Okay? All right, take a look at number 3. Circle what's behind the minus and take the derivative. What would it be?
X squared minus 3x.
But we want to take the derivative.
Okay, so 4 negative 4.
Negative 4x minus
3.
3. Now notice the behind the minus is behind this minus. So remember that this little minus in here, we're going to keep it. Okay. All right, take a look at number 5. You'll notice that your equation has an x plugged in. Okay, but we know that our x is really a 2. So I'm going to rewrite it back as an x. I'll take the derivative and then I'll plug the 2 back in.
X is 2.
Yep, but I have to turn it back into an x so that I can take the derivative and then plug the 2 back in.
Okay.
And actually I wrote this should be a 4, yes?
How do you know?
Because in the formula, this is an x plus h. And so if they're replacing the x with a 2, we just want to turn it back into x stuff so we can take the derivative. Okay, then what are we going to circle? X4. What's the derivative of that?
4 x cubed.
4x cubed. And then I'm going to plug in
2.
x equals 2.
Okay, so
Very good.
So the objective is 8.
Say that again.
You have to cube it such that.
Yes. Uh-huh.
And down.
So 2 cubed is 8. 4 times 8 is 32. Very good. All right. So a little bit of your homework is that.
Okay.
Okay. And then the other thing your homework asks you to do is to start with the equation and type out the limit. So this is not horrible. You can do it, but let's practice. Okay. Write your definition one more time so that you have it. LIM, h approach 0. F of x plus h minus f of x over h. Okay, the parts of that never change are the LIM h approach 0 and the h on the bottom.
Yep.
So if I wanted to do this question, I'm going to put, so this is just like generic, okay, not for this question specifically.
Okay.
I would put LIM h approach 0 over h. That never changes.
Okay.
Okay, but then for the top, my original f of x goes behind the minus, and the one that I put before the minus needs to have the little h buddy, right?
Okay.
So if my equation is a 7x to the 4, it'd be 7x plus h to the 4
Okay.
minus 7x to the 4.
Oh, wow.
You're just gonna type it in. So it's gonna ask you to write the limit definition of taking the derivative of that function. Let's do one more. LIM, this part never changes. H approach 0 over h. This time my function is a 5 sine x. Where does 5 sine x go? Before or after the minus? It needs to come after, and the one before is going to sneak a little h in with it. So it'd be 5 sine x plus h minus 5 sine regular x. But remember, whatever your f of x is comes behind the minus, and what goes in front of the minus should be the little h buddy snuck in.
Okay.
Good?
Yes.
Okay, next one, write it down. LIM. H approach 0.
Yep.
H on the bottom, that part never changes.
Okay.
My function is a 6 tan x, so I do 6 tan x plus h minus 6 tan x. Everybody good so far?
Yep.
Yes? Because that's the equation that we're using for the problem. So this 5 sine gets an x plus h, and then the one that comes behind the minus is regular 5 sine x. So you're sneaking an h in before the minus. Okay, now number 8 is not fully done. Here's why. Okay, it doesn't say at any value of x. It gives me a particular value of x. What x do I want?
Pi.
Pi. Then everywhere that I see an x, I'm just going to turn it into a pi. So your LIM, h approach 0, is now going to be a 6 tan pi plus h minus a 6 tan pi over h.
Anywhere there's a x, you're just plugging in that number.
That's right. But notice the difference in the instructions. If I want it at a particular value, I have to plug that value in for x in the limit.
I got it.
Okay, versus at any x, I can leave it as a letter.
Okay.
Can you do the last one?
Yes.
Okay, do it.
It's worse.
What is it being worse?
What, Seth? What do you think? Who said that?
All right, look up and check your work once you've done it. Are we good on that? Did you say absolutely not?
Yeah.
Step by step.
Yeah, I'm doing.
Yeah, do it step by step if you want. This would be your final answer after you've switched the x's to 2's.
That's what.
You get it?
All right. Are we okay? Yes? So that's the x plus h, but then we turned the x into a 2.
We love it.
All right. Can we go to the next page?
Yeah.
All right, turn the page. All right, so this is the new part for today's lesson. So everything we just covered, technically you've already learned. Okay, so on the next page, I want you to change the x plus h to an a. Okay, so this is the alternative definition for taking a derivative. There are 2 of them on the AP test. You already know the h approach 0 one. This is the second one. Okay, you are still going to find the slope of the secant line, but instead of calling one x and one x plus h, we're just going to call one x and one a. So you would do f of x minus f of a over x minus a. Now, that is the slope of the secant line. Because remember, a secant slope crosses through 2 different points. One of them we're calling x, one of them we're calling a. Okay, then remember, my goal is to drive that secant line to a tangent line, yes?
Shouldn't it be the other way around? F of A minus F.
That is a great point. When you are doing the slope formula, it actually doesn't matter which way you subtract, and they're going to put f of x in the front for this one. Okay, so remember what our goal is to turn our secant line into a tangent line by getting our points really close together, right? So for your tangent line or your tangent slope, you're going to still use a limit, but rather than having an h in the way, you're just going to push x directly towards what that a is. Okay, so let me explain it one more time. Remember what our goal is. The reason h went to 0 is because that was the space between the 2 points. So h went to 0. Now, to have the same concept, we're going to take our x and just drive it towards a. So that would essentially still push the points closer and closer and closer together to where it's like you're only touching one point. Okay, but you're just using a different method. Okay.
You need to find a tangent or the secant slope. It'll tell you.
So a derivative is a tangent slope.
A derivative.
So this would mean the derivative at A.
Okay.
All right, so let me show you just functionality, how this works.
Okay.
Okay, take a look at number 10. First question, can you take the derivative of x squared using your derivative rules?
Yeah.
Yes, what would the derivative be?
It would be 2x.
2x. Okay, shh. What if I wanted the derivative at 3? What would I do?
3.
Oh, sorry, over here. I would just plug in a 3. What's 2 times 3?
6.
6. So I know that the tangent slope at 2 is 6. You already know how to do this with your derivative rules. Now what we're going to do is write this limit statement, and then we're going to solve it using the limit strategies that we learned last class. So it's a little bit of a different setup, but you can do it. Put LIM, x approach, and then the number that I want the derivative at.
So 3.
It would be a 3. Very good. So in this case, x is going to always approach the number that you want the derivative at, not h approach 0. Okay, then I'm going to do f of x minus f of a. So in this case, what's my f of x?
X squared.
X squared. I'm going to write it 2 ways. I'm going to start by just keeping it in that same form, and then I'm going to plug in specifics.
Okay.
That way you can maybe follow it easier.
So then let me do that thing.
So it's f of x minus f of a over x minus a, but remember our a's are all turning into 3's, yes.
And they're turning to
Because we're asked to take the derivative at 3. Okay, so f of x is what function? X squared.
Yep.
And then f of 3 would be 3 squared, which is what?
Which is 6.
Nope, 9. That's okay.
Yo, what?
Very good.
Oh, you're plugging in.
Yeah,
X.
you're plugging it into here. So if I did the little step that I did on the last questions, do you remember we said f of x is x squared?
Yeah.
Then f of 3 would be 3 squared.
Okay, got it.
Okay, we like that?
Yeah.
All right, now, this is what you would type in for your homework when it says write the limit. Okay, but now we're going to practice solving it using the strategies we learned last time. What strategy is this kind of set up for? Factor cancel.
Yeah.
How can I factor the top?
Plus or minus.
Plus or minus 3?
Wait, what is the bottom?
Just x minus 3.
Still, it's minus.
And then after I factor the top, remember the name of the method is factor what? Cancel. Very good.
Yes.
So I can cross out my x minus 3's. Once I've factor canceled, what do I do with my x approach number? Plug it in. So 3 plus 3, what would that give me? 6.
Oh.
And what did we get when we did it via derivative rules?
You were just doing one rule and then the other.
Yeah, so first we did it with your derivative rules, and then we did it using the limit and the limit strategies that we just learned. Okay, turn the page. All right. First thing we're going to do is the easy way, using the rules. Your equation is an x cubed. What is the derivative of that using your rules?
3x squared.
3x squared. If you were asked to find the derivative at 2, you would just plug a 2 into that. So it'd be 3 times 2 squared. It'd be 3 times 4, which would be 12. Great. So 12 is the final answer that I'm expecting at the bottom of part B. All right, let's write our limit.
You're just trying to prove why it's 12.
You're proving that it's 12 using the definition, correct? Yes, see, I'll show you how it's tested on the AP test. So put LIM. Now I want the derivative at 2, so my x is going to approach 2.
Yep.
And then it's f of x minus f of 2 over x minus 2. Now, one thing that is important to note is that in this version, where does the f of x come? Before or after the subtraction? Before, versus in the H method, it comes after, right?
So everywhere that you're plugging your 2 is basically your A.
That's right.
Okay.
So if my f of x is an x cubed, what would my f of 2 be replaced by?
2 cubed.
Which is 8. So this is LIM x approach 2 of x cubed minus 8 over x minus 2. And that's what you would type in for your homework if it was asking you to write the limit. Okay, but we're going to use our strategies from last class to solve it instead. So, unless you remember how to factor x cubed minus 8, factor cancel isn't going to work. Could I use L'Hopital's rule?
Yeah.
Okay, remember, L'Hopital's rule is where you do both derivatives and then try again.
Yeah.
So that's the one that we're going to pick this time.
Okay.
So, L apostrophe hospital.
Did you not do substitution for this?
That's a great question. What am I going to get if I plug in a 2 on bottom?
Oh, 0 and 0.
And 0. And that means do more, which is where you would have to pick a strategy from last time. Okay, so L'Hopital's rule says take both derivatives, try it again. What's the derivative of the top?
You have 3 x squared.
Okay, minus 8 goes to
0.
x goes to
1.
and then I just try the limit again. And if I plug in a 2, I'd have 3 times 2 squared, which also gives me 12.
Got it.
Now, notice, why couldn't I have taught you this when we did the other? Because we hadn't learned L'Hopital's rule yet, right?
Okay.
All right, go to the last page, almost done.
It doesn't feel very useful in this context.
It doesn't, you're right. Okay, find f prime. Actually, we're gonna just do a little skip here. Let's just write the definition and then we're gonna go on. So LIM.
Yeah.
What is my a value this time that x needs to approach? 9. And then remember, it's f of x minus f of 9 over x minus 9. Okay, then I'm going to get specific with what my f of x and my f of 9 are for this question.
Right.
What is it? Tell me f of x is.
4
root x. And what would f of 9 be if I plugged 9 into that? What number?
3.
It would be a 12. Very good. Because it'd be 4 times 3. That's right. So then the limit that you would type in for your homework would be LIM x approach 9 of this minus this.
Wait, hold on. Will you write?
Sure.
Thank
Mhm. Now, if I made you pick a method, what method do we pick for stuff with square roots?
You do conjugate.
You would do the conjugate, which I'm not going to make you do.
Oh,
Okay, but you would use conjugate method if you wanted to solve this one out the long way. You would use conjugate method because if you plug in 9 for the limit, you'd get 0 over 0. And that would mean that you have to do more. And out of the strategies, conjugate is what we do for square roots. Okay, you get the idea?
Yeah.
Turn to the last page. Let me show you how it'll be on your homework. There are 2 types of questions that you're going to see for this limit. Okay, the first one is you're just going to circle the function, take the derivative. You already know how to do this, except where is the f of x in this formula in relation to the subtraction?
It's in the front.
It's in the front. So you would circle and take the derivative.
If there's no h, it's in the front. Or if it's
Correct.
approaching a number.
If it's an x approach, your f of x comes at the beginning.
Okay.
So what's the derivative of that?
6x squared.
You got it. Take the derivative. That gives me 6x squared.
And you have
And then what is my x approach number?
4.
Plug in 4.
The x approach number.
So it'd be 6 times 4 squared.
48.
Do the 4 squared
6.
first.
16.
96. Very good. Okay. Take a look at the next one. Circle what's in front of the minus, because we notice this is the definition of taking a derivative, and we already know the shortcut.
Yeah.
So circle it, take the derivative. What is it?
So 4 minus 2x.
And then what are we going to plug in?
3.
4 minus 2 times 3 would be 4 minus 6, which is -2. Okay?
Yep.
Okay. One more like that. Circle what's in front of the minus.
What's up with 15?
It's a 2/3 x. Now, I want you to rewrite this. That is a 2/3 x to the 1. Okay, because 2/3 is the number in front, and then my x, if it's regular, it's to the first power. So let's take the derivative.
And it's minus 2/3? Oh, no.
Nope,
The
it's
minus
regular.
is the f of a.
Is part, that's right.
Got it.
It's part of the definition. So it's 1 times 2/3. And then what happens to my x when I drop it a power if it's already a 1?
It goes to a negative, right?
Nope,
No.
it go to 0.
Oh,
So remember, if it's a regular x to the 1, you just keep the number in the front, right? Because the 1 times down and then the x goes away.
when do you do the -1 or?
Let's go to number 16 and you'll see. Okay, so number 16, circle what's in front of the minus. Where is my x this time in relation to the fraction? So when I take my derivative, I'm going to rewrite that as 5/3 x to the -1. Because it is a regular x, but it's coming up from the bottom.
Got it.
So when I take the derivative, what's -1 times 5/3? And then when I take away one more from -1, I get -2.
You gotta rewrite it, right? Again.
Okay, then we're gonna rewrite it so that we can plug in our x. And x to the -2 really belongs on the bottom, which means it'd be a 5/3x squared together. That's right. Because after I take the derivative, I have to plug in the x approach. Now, quick question. Why didn't I have to plug in an x on this one?
Maybe because the x
Yeah,
went
the
away.
x went away. There's nothing left to plug it. So you already had your answer. Versus if you do still have an x, you want to plug in your x approach.
Now we're gonna do it.
So it'd be -5/3 times 3 squared, which would be -5/27. Okay.
Okay.
All right. We'll just do one of these. Let's do 17 since we already did 10. Okay, circle what's in front of the minus. It's a sine x. What's the derivative of sine x? Cosine x. And then just keep the 8 in front. So it'd be 8 cosine x. Then we're going to plug in what? My x approach is what number? 4π3. Okay, let's review how to do a non-quadrant 1 angle. Which one's your π3 finger? Pointer. And cosine is which way? Up or down?
Up.
Up. How many fingers are up? So it'd be a half. But then I have to decide if my half is positive or negative using all students take calculus. Okay, very good. So the top half of the circle is 1 full pi. So I would measure that as 3 π3.
Yes.
Then where would 4 π3 tilt me into?
T,
Which means tan is positive, but cosine would be negative. And then 8 times -1/2 is -4. Very good. Get the idea?
Yeah.
Okay. Last two. We're going to skip 18, go on to 19. The other part of your homework is you writing the limits. Remember, for these limits, x approaches the number.
Yeah.
So if I want the derivative at 1, what is my x going to approach in the limit?
It's gonna approach 1.
Yes? Say that again. Because it was cosine, not like secant. Secant is the one where you have to flip it. So LIM, x approach 1. Okay, and then on the bottom, it's going to be an x minus 1.
Yeah.
Now, on top, it's going to be f of x minus f of 1. So I'm going to write it first like that, and then I'm going to plug in for this particular function. What is my regular f of x?
It's e to the x.
So it'll be LIM x approach 1, e to the x plus 5 minus, and then in f of 1, I would have to plug that 1 in for the x. So it'd be e to the 1 plus 5. Now, if you type it in Delta Math as a 6, that's fine. It'll count it either way as correct. Okay, and then over x minus 1. That would be your
E to the
answer.
1 is just 1, right?
Don't solve it. You're just typing it in.
E to the 1 plus 5.
Uh-huh. Cause it doesn't make you.
If it was a 0, we'd just do it, right? We put 1 plus 5 and do 6.
Sure.
But you would have.
Yeah, for this homework assignment, it just says to type it in its original form.
Okay.
Okay, we're gonna do one more, then we're done. Okay, LIM, X approach what? 6, because I want the derivative at 6. Then it's f of x minus f of 6 over x minus 6. Now let's get specific for our function. What is my f of x function?
Your f of x function is 2x to the 4th.
2x to the 4th minus 6 to the 4th.
So plug in 6.
And I'm going to type it in just like that.
Oh, really?
Because what your homework says is that you can type it in any form. So could you find what this number is if you want? Sure, Delta Math will count it right, but you don't have to.
Okay, right.
Okay, you can do it?
I can do it.
Okay, take your time, go slow through it so I don't have to reset you all a million times, but do your best. But you know, I still will reset you a million times if it's needed.
Okay, that was.
Was that, did that make sense? Do you like it?
I liked it. Scratch it. Don't please. You never plug in that X to the bottom. Yeah. Only the top. So I'm gonna pick one up. Because we plug.
Well, you are plugging it in here. So, because remember, the bottom is x minus a. So whatever your x approach is here, it's always going to be the same here. So what I would think about is in the front, they're regular x's. And then behind the minuses, you're plugging that number in. Okay?
Where do you find out what the
Yes. Did you put a pass in? It's okay. I'll do it.
I'm gonna do a super score, which is like the best one.